Physics students, good afternoon. Mr. Fugit here. What we're going to be looking at today are some problems from review number 1. Physics students, good afternoon. Oh, there we go. Physics students, good afternoon. Mr. Fugit here. Today in our videos, what we're going to be looking at are some problems from your review over test 1, which covers over our unit 0 on density, as well as unit 1 on vectors. So here what we're going to be doing is working through some of the problems from the review, and there will be several different videos that cover over all the problems on your review. So copies of your review, do not forget, are accessible on Canvas in the unit 0 and unit 1 pages. There's also a key for all the problems located on Canvas as well. So the first problem that we will look at is the first on the back side, which is problem number 13. And our problem statement says this: I have found a decorative cube at an antique store. It has sides of 3.5 centimeters. I judge the mass of the cube to be about 360 grams. So we know a few things here. We know we're dealing with a cube. We're told the mass of the cube is approximately 360 grams. And we're told that the cube has sides of 3.5 centimeters each. Okay? Next sentence says this: what material might the cube be made of? In parentheses, use the table at the top of the sheet. Now the table gives us a few pieces of information. It gives us some volume equations, as well as some density values. So in order to determine what material the cube might be made of, we are likely going to have to find a density value. Now density, as we've talked about, rho is equal to, well, it's a ratio of mass to volume. So we know the mass of our object, but we don't necessarily know its volume. We know some dimensions, but we're unsure about the volume. So the first thing we'll need to do is find our volume for a cube, which we know to be length times width times height. Now, we're told the cube has sides of 3.5 centimeters, which just means all sides, the length, the width, the height, would all be 3.5 centimeters. So 3.5 times 3.5 times 3.5 would just give us 3.5 cubed, or to the third power. So we'll plug our values in, 3.5 to the third. That should give us approximately 42.88 cubic centimeters. 42.88 cubic centimeters. Okay? Now that we have our volume, we are given the mass directly, so it's just a matter of using our density equation. Rho is equal to mass, 360 grams, divided by our volume, 42.88 cubic centimeters. So now we'll plug in to see what our result would be. 360 over 42.88. We got approximately 8.396. So we can round to about 8.40. And our units here would be mass over volume. So grams per cubic centimeter. Okay. Now the question doesn't ask us to solve for the density. It wants to know what material the cube is made of. So we need to take this one step further. Looking at our chart, it appears that the closest value would be brass, which is listed as 8.5 cubic centimeters. Okay? So that is how we would make our determination on number 13. Okay? Given a mass and the dimensions of our cube, we first solve for the volume, and then we use that to find density, which we can then use as a determination of the material. Okay, so now we're going to jump on. We're going to move to problem 14. 14 says this: to celebrate Talk Like a Pirate Day, September 19th, I want to make a tiny model cannonball. It will be made of iron and a ball with a diameter of 5 centimeters. What will the mass of the cannonball be? So here we have, in problem number 14, we have a ball, which geometrically we would refer to its shape as a sphere. We're told the ball is made of iron, which again, anytime we know a material, that's going to tell us what our density would be. So looking at our chart, we can use a density of 8 grams per cubic centimeter. And we're told the sphere has a diameter of 5 centimeters. Now right off the bat, when we're given a diameter, I'm going to go ahead and convert that. Remember, radius is half of our diameter, so that would be 2.5 centimeters. Remember, all of our, not all of, but our volume equations for both the cylinder and the sphere use radius versus diameter. So anytime we're given a diameter value, we need to immediately convert that to a radius. So here, we have all of this information, and the problem asks us for what is the mass? And how do we find that? Well, in order to find mass, we probably need an equation where the mass shows up. So we're dealing here with densities, with dimensions of a shape, with mass, which probably means we're going to go with our equation for density. So density, rho, is m over v. Now, just using the equation itself, I can go ahead and rearrange my equation to set the m term by itself. So I can multiply by volume. If I do that on the right side of my equation, I would need to mirror that on the left side. So v divided by v, those will cancel out. And now I'll rewrite my equation in terms of m. I'll have m, well, now that it's by itself, m is equal to volume multiplied by density. Now, that's not the answer we're looking for, but it's a way to get to the answer, right? So, we know the density because we're told this is an iron cannonball. We just need to figure out what the volume will be. So, let's do that. We're told we're dealing with a ball here, which we can model as a sphere. And the volume equation for a sphere. If you're unsure, remember on your review there are volume equations for any geometric shape I'm going to ask you about. So if we check there, it should be the equation 4/3 pi multiplied by our radius cubed. Now remember, we're given a diameter here, not a radius. So we're going to use our radius value that we determined, which was 2.5 centimeters cubed. So now it's a matter of plugging in mathematically. So 4/3 times pi times 2.5 to the third power. Whoop. That should give us a value of about 65.45. Our units here would be centimeters cubed because we took centimeters and we cubed. So now that we have our volume, we also know our density, it's iron, so we can use that to determine our mass. So mass, according to the equation that we have, is equal to our volume, 65.45 cubic centimeters, multiplied by our density, 8 grams per cubic centimeter. Also remember the units are a good way to double check that our equation is appropriate. We have centimeters cubed divided by centimeters cubed, which should leave us with units of grams. So when we multiply 65.45 by 8, we should get a mass value that is right at about 523.6. You can round that to 3 significant figures to be 524 grams. So again, we're still using our equations for density, these relationships of mass and volume, and our volume equations, and to solve for an unknown mass value. What would the mass of our cannonball be? So as you're seeing, there are a lot of applications with how we can use our equations for density and the volumes of our different geometric shapes.